Solving systems of equations using Cramer's rule. We'll talk about what a matrix is, what the determinant of a matrix is. Can we always use Cramer's rule? Some people really like it and want to always use it, but you can't always use it. And then make sure you have a good method to know what gets replaced. What is a matrix? Matrix, or plural, matrices, just like vertex, vertices. It's just a collection of numbers. And if you think about the movie, why it was, it's just a collection of numbers in rows and columns. So every spreadsheet is just a matrix of sorts. It just doesn't happen to have numbers necessarily. It can have numbers. But this one that I just drew happens to be 2 rows and 4 columns. Columns go up and down like the columns of a building. Rows go across. And you can have any number of rows and columns. We're going to be dealing with square matrices. Right now we're going to be dealing with 2 by 2s, 2 rows, 2 columns. And later we'll deal with 3 by 3s. You can look up what are uses, and it has a lot to do often with photography. It has an awful lot to do with 3D images, especially when you get to 3 by 3s. So you can check that out, do some Googling, find something good, let me know. I did a little bit of looking. Most of it just, wow, way up there stuff. So how do we evaluate the determinant? The determinant is going to be a value we can come up with for these numbers. And determinant, I like to remember determinant starts with D. And so finding the determinant, we're going to be finding the difference of some numbers. So difference means subtraction. We're going to take those 2 numbers, multiply those, and then subtract these. So we read a matrix from the top left. I like to think about it as just like reading a book. You start reading a page, top left. You start reading matrix, top left. And so we do our multiplication. So you can see you're going to have all kinds of integers, positive, negatives floating around. You've got to get those rules right. If it helps you to do plus negative, do plus negative. And so 10 plus negative 18, negative 8, the value of that one. If you're ready to try one on your own, pause the video, try this next one on your own. We love when we see zeros in a matrix, because then we're not going to have a whole lot of math to do. So these were the numbers that went in green. These were the numbers that went in blue. Negative 2 times 0, 0. 1 times 9, 9. Again, 0 minus 9, that negative belongs to that 9. So 0 plus negative 9 is negative 9. If you weren't ready on the last one, let's do one more. If you didn't try the last one on your own, please try this on your own. 4 times 3 minus 6 times negative 8. 12 minus negative 48 minus a negative. So we add, and we get positive 60. So that's just finding the determinant. That doesn't do a whole lot on its own, but we can use that to help us solve systems of equations. We've learned a couple other ways to solve systems of equations, and so we're going to be solving this system of equations using another method. You can't say, oh, I don't need to know this, I already know 2 methods. You need to know all the methods, and when I ask you to do a specific one, you need to be able to do that specific one. Might help some of you to write a 1 in there. But if you are good at one, better at one than another, if you're asked to use a specific one, you can always do the other one to double check. So it says that step 1 here is to write the coefficient matrix. Remember, coefficients are the numbers in front of the variables. So those are my x coefficients, 1 and 2, and those are my y coefficients, 3 and 7. I've got this first one here all nice positive numbers, so we don't have to worry about too many negatives here. And so writing the coefficient matrix is just pulling out those numbers, 1 and 2, 3 and 7. Now we have a matrix just like we had in the last problems. We just created it ourselves. So then we're going to evaluate that. And so we're going to do our from the top left to the bottom right minus bottom left to the top right. 7 minus 6, 1. Okay, we're going to use that later. We're just going to let it sit there for now. But the big thing is, this cannot be 0. If it's 0, you can't use Cramer's rule. You're going to have either infinitely many or no solution, and there's no way to tell with Cramer's rule. So you can only do Cramer's rule when you have a determinant of the coefficient matrix is not 0. So now we're going to move on to a couple more matrices, and I like doing these at the same time. Didn't plan my screen real effectively here for what I'm working with, but that's okay. We can do this. So we're going to do the x coefficient matrix and the y coefficient matrix. Now, the coefficients get used once, but not both places. What I mean by that is we're going to use those constants that we haven't seen yet, right? We haven't used these guys over here yet, right? So we're going to use those first. And I like to do these first because this is the biggest stumbling block that students have, is how do I know what numbers go where? So I'm going to fill in those two constants, the numbers that come after the equal sign, first in both of these two matrices. I'm going to put negative 6 in place of the x coefficients when I'm looking for x, and I'm going to put the same thing in place of the y coefficients when I'm looking for y. So we already used those numbers twice. Okay, we use them when we're looking for x, we replace the x coefficients. When we're looking for y, we replace the y coefficients. And then we're going to use the other coefficients each once more. We're going to use the x coefficients once more and the y coefficients. They have to stay in their assigned spot. They cannot move. I think of it that the constants don't have an assigned spot, so they get to jump around. But the y coefficients have to go in the y row or column, and the x coefficients have to stay in the x column. So now we've used those 6 numbers we had to start with, we've used them all twice. We use the x and the y coefficients in the coefficient matrix and in the opposite matrix of what we're finding. And then we use the constants in each the x and the y matrix. They get to move around. The x and the y coefficients don't get to move around. They just get to disappear out on 1/3 of the time. So now we just do the math. Evaluate this. We've got -2 times 7 minus -6 times 3, -14 minus -18. So we've got 4. And then for the y, same deal. We've got 1 times -6 minus 2 times -2. We've got -6 minus -4 plus, so we get -2. So now that we have those, it says in the last step, divide each of those by the determinant of the coefficient matrix to get the ordered pair of your answer. I'm actually going to go back up to the top to do it because that's how I usually do it in my work. I just put those steps on your assignment to remind you of the steps. So to find the x, I'm going to take that 4 and divide it by 1. And to find the y, I'm going to take that -2 and divide it by the 1. So this went both of those spots. This came up here, and this came up here. And so 4 divided by 1 is 4. -2 divided by 1 is -2. You will get some fraction answers. Don't think just because you got a fraction you did it wrong. You're still going to check your answers. I'm just going to do it verbally. 1 times x would be 1 times 4. plus 3 times negative 2, so I would have 4 minus 6 is negative 2, so that checked. And then 2 times 4 is 8. 7 times negative 2 is negative 14. So 8 minus 14 is negative 6, so that checked. So I know that's the right answer. I'm not going to ask you to show your checks, but you should be able to just kind of talk your way through it. Do this one more quickly. I don't have the framework. This is just like what I would do on notebook paper. And I like to do my box, and I like to do my answer blank. So we're first going to set up the coefficient matrix. And I like to label it, just abbreviating. And so our coefficient matrix this time is going to be 3, 2, negative 1, negative 2. And you know me with signs, I like to double check. Positive, positive, negative, negative, positive, positive, negative, negative. Okay, good shape. I'm going to evaluate that. 3 times negative 2 minus 2 times negative 1, negative 6 minus negative 2, negative 4. Now I'm going to do my x and y's. Again, I like to do those at the same time. I know I'm going to use those constants twice. I like to get those out of the way first. When I'm looking for y, the constants replace the y. When I'm looking for x, the constants replace the x. Now I just use my y value coefficients, my y coefficients, when I'm solving for x, because they can't move position. That's the only column they can go in. And my x coefficients, when I'm looking for y, this is the only column they can go in. And then I just do the math. So I have negative 4 times negative 2 minus negatives all over the place. Negative 1 times negative, or negative 8 times negative 1. So I end up with 8 minus 8, which is 0. That's okay. We can have a 0 because that's going to be in the numerator. So that answer is just going to end up being 0. We can take 0 divided by some number. We just can't divide by 0. Going this way, we're going to have 3 times negative 8 minus 2 times negative 4. This time negative 24 minus negative 8 plus negative 16. So where do those guys go? I'm boxing them, but they're not really our answers, because for our answers, we're going to use them up here. And to find our x and our y, we're going to use both those numbers. We're going to divide our coefficient matrix value is going to go there, the determinant of our coefficient matrix. Our x value is 0. 0 divided by negative 4 is 0. Our y matrix got us negative 16. Negative divided by negative is positive, so our y value is 4. So our ordered pair answer is 0, 4. We can check our answer. If we were really not confident, we could use substitution or elimination. And one thing I didn't write it on the previous slide, I probably should have, make sure these have to be in standard form in order to use Cramer's rule. Sorry I didn't put it on the first slide, but there it is. So if they're not in standard form, you'd have to put them in standard form first, or at least get the x and the y terms, lined up and on the left. And so I'm just going to do my quick check. Since I know I've got a 0 for x, I don't even really have to deal with those, right? So I just plugged in my 0. So negative y would be negative 4. Negative 4 equals negative 4, yep. Negative 2 times 4 is negative 8, yep. So both of those work. So again, I just did a little verbal check. I don't have to do the work on paper. So matrix, we saw what it was. We saw what the determinant was. We can only use Cramer's rule if we don't get a 0 for that coefficient matrix. And in order to use it, we've got to get it into standard form if it wasn't. And then make sure you have a good way to remember what gets replaced where. Right? I kind of showed you my little trick there. So if that works for you, great. If not, develop your own.